Yeah, hello everyone. Good afternoon. Good afternoon, guys.
After
Good afternoon, everyone.
good
So,
afternoon.
I hope I am visible and audible to all of you. Can you able to see me? Am I
Yes, madam.
audible?
Yes, madam.
Yes. Is my screen visible for you?
Yes, madam.
Okay, great. So let's start with the today's session. So today we are going to start a new chapter, and which is the first chapter of your class 12 chemistry, that is solutions. Okay. So before moving on to the class, I just want to ask you guys some questions. Okay. Yeah, good afternoon, everyone. Hmm. So, has this lesson been taught in your school?
Yes, madam.
Yes. Okay, fine. So let's do this lesson from JEE and NEET point of view. And coming to the learning objectives of solutions lesson. So today we are going to study about the solution, introduction to solution and its concentration. And next, solid and liquid solution and gas and liquid solution and Henry's law. Okay, so we will try to cover as much as possible in today's class. Okay, so moving on to the first topic, which is solution and its concentration. Yeah, solution and its concentration. So, what is a solution basically? So, solution is nothing but solute plus solvent, right? Solute, we have a solute and we have a solvent, and they mix equally in the container with each other, and we call that a solution, and it is a homogeneous mixture of a solute and a solvent. Got it? Which is called a solution. So in the picture which you can see on the screen, so we have a substance, and that substance is a solute. The substance is a solute, and here water is a solvent. Water is a solvent. Okay. And in all the cases, in most of the cases, if you see, the solute will be present in very lesser amount. Okay. And the solvent will be present in greater amount. Got it? So this is the case for all the solutions. Always solute will be in lesser amount and solvent will be in some greater amount. And they lead to the formation of solution. Got it? So now I'll give you some pictures. I'll give you some pictures. And this is a picture of aerosol. And here is a picture of bronze. And next we have brass. Fourth, we have cool drinks. Okay. And fifth, perfumes. And at last, I have given R. Okay. So can you tell me whether these are solutions or not? What is your idea? And what is your answer for this? Are these solutions? Yes or no? Yes. So many of you are going for the answer yes. Okay, good. So, but how come this bronze is a solution? How come this bronze is a solution? How bronze is a solution? Can anyone explain why bronze is called as a solution? Yeah, very good. It is a mixture of solid and solid. So we have different types of solutions. Okay. So very good, Rohit. It is a mixture of two metals. Metals are actually solids. So they are the alloy mixture. That's also correct only. So one solid is mixed with another solid and it is also called as a solution. Okay. So we do have different types of solution and that's what we are going to see here. Okay. So first is on the basis of appearance. There are three types. First is on the basis of appearance. Second is on the basis of physical state. And third is on the basis of amount of solute. Okay. So these three are the classifications of or the types of solution. Okay. So let's do this one by one. First, let me go with the type of solution from the basis of appearance. On the basis of appearance, so I'm taking a beaker which has a solvent inside it. Now I am adding a solute particle to this solvent. Okay. And it may give a mixture like this. Okay. So what is this? Is this a homogeneous mixture or heterogeneous mixture? Homogeneous means everything will be mixed evenly. Okay. Everything will get mixed evenly and I mean uniformly also you can say. Heterogeneous means no uniformity is there. Some amount of particles will be at the bottom. Yeah, very good, Harish. It is a heterogeneous mixture. It is a heterogeneous solution. Okay. And there is one more option. Okay. So this is the other option. Now what is this? So the solute particles has got mixed with the solvent particles in a uniform manner and it leads to the formation of homogeneous solution. Okay, it leads to the formation of homogeneous solution. Now, on the basis of appearance, we are classifying the solution into homogeneous and heterogeneous. Okay, yeah, very good. Very good. JNV, North and Middle Andaman students, very good. The second one is the homogeneous mixture. Good. So what we are doing? By just seeing the solution, we can able to classify it into homogeneous and heterogeneous. Okay, this is on the basis of appearance. Now, secondly, coming to the on the basis of physical state. So in this classification, if you see, we have three main category, three main types. So in this tabular column, you can able to see, right? So the first main type is gaseous solution, second liquid solution, third is solid solution. Okay. If it is a gaseous solution, the solute should be, the solvent should be gas. All the solvent thing should be a gas. And if it is a liquid solution, all the solvent molecule should be a liquid. And if it is a solid, it should be a solid. Okay. And the solute can be of different physical natures, physical state. One is a gas and the other one is a liquid, third is a solid in all the three cases. Okay. If we are calling a solution as gaseous solution, then the main particle, the component which is present in very greater amount will be of that particular thing. If it is a gaseous solution, the solvent is a gas. Okay. So don't forget this. This tabular column is very, very important. Okay. And the common examples which we are going to discuss here are very, very, very important. Okay. You should not forget. If you understand, you will not forget. Got it? Because in the NEET exam, they will give 4 options. Okay. They will ask us to find out the one which is an example for gas solution. Find out which among the following is a liquid and gas solution. Which among the following is a solid and liquid solution? So such kind of question will be asked for your JEE and NEET. So to remember or to memorize all these things, understanding is enough. Okay, if you understand, you don't have to memorize. Okay, so first let me go with gas and gas. So here the example is the mixture of oxygen and nitrogen. So both are gases, right? O2 and N2. Oxygen is also a gas. Nitrogen is also a gas. So gas and gas. The second one is liquid and gas. So example is chloroform mixed with nitrogen gas. So nitrogen is a gas, we all know. Chloroform is a liquid. Can anyone give me the formula for chloroform? Can anyone give me the formula for chloroform? Yeah, it is CHCl3. It is CHCl3. Very good. So chloroform is a liquid, CHCl3. So it is mixed with the gas, leading to the formation of liquid in gas solution. Okay. And next, camphor in nitrogen gas. Camphor you all will be knowing, right? We all use that in our home and it gives good smell. So it is a solid actually. So that particular solid is mixed with the nitrogen gas. Okay. Coming to liquid solution. So here solvent is a liquid and in all the three example, the solvent here is taken as a water. And for gas in liquid, the gas is oxygen here and liquid in liquid, ethanol is taken here. What is the formula for ethanol? What is the formula for ethanol? Any idea? Have you ever seen ethanol? Or have you ever noticed people having ethanol? No, the answer is wrong. It is not CH3OH. CH3OH is methanol. Yeah, very good, Bharat. C2H5, yeah. C2H5OH is ethanol. CH3COOH is ethanoic acid. Okay, Rohit. So it is ethanoic acid. Good. So C2H5OH is ethanol. So many people are drinking, no? So that is the ethanol actually. Methanol is actually poisonous. So methanol cannot be used for any purposes. So it is poisonous. So liquid, ethanol is a liquid and it is dissolved in another liquid which is a water. Okay. And the last one is solid and liquid. Solid and liquid. So glucose is a solid. What is the formula for glucose? What is the formula for glucose? C2H6O6. Very good, Sneha. C6H12O6. Yeah, Suraj, good. Rohit Mugilan. So many of you are giving me the correct answer. So C6H12O6 is the glucose molecule. Okay. So it is a solid. It is a solid and it is dissolved in water. Fine. Now coming to solid solution. So the solvent molecules are solid. And coming to the first example for this, first type in this, gas in solid. So the example is solution of hydrogen in palladium. Hydrogen is a gas and it is getting absorbed in palladium. Palladium is a metal. Okay, it is a D block metal. It is a D block metal and metals are actually solids. So on the surface of this palladium metal, this hydrogen will go and get absorbed and they form a solution. So this is an example for gas in solid solution. Okay. Next, liquid and solid. So it is an amalgam of mercury with sodium. So all of you might have seen in some reaction, like mainly in organic chemistry. So we see this kind of thing, no? Above the arrow. In some reagents you might have seen. Yes or no? Have you ever seen this kind of thing above the arrow in organic chemistry reactions? Sodium amalgam. It is called as sodium amalgam actually. It is a mixture of mercury and sodium. Amalgam of mercury with sodium. Okay. Sodium is a metal. Solid. Sodium is a metal, so it is a solid. And this mercury is actually represented by Hg. It is the liquid metal. Mercury is only liquid metal. So have you ever seen mercury anywhere? Has anyone seen mercury in any of your places where you used to go? Very good. It is present in the thermometer. Okay. So the thermometer you might have seen in your labs, in chemistry lab or physics lab, in your school labs, you might have noticed in the thermometer, it will be present at the tip of the thermometer. Okay, it is a liquid metal actually. Got it? So that is mercury. And lastly, coming to solid and solid, I have taken copper dissolved in gold. So copper is a metal, D block metal. Okay, it is a solid, and gold is represented by the letter AU. It is also a solid. So when these two gets mixed with each other, and they form a solid and solid type of solution. Got it? So this is how you should understand and study the examples. So all the examples are very important. Clear for all of you? So any doubt? Is there any doubt from this physical state classification for anyone? Is everything clear? Okay, fine. Great. So let's move on to the, okay. Okay. So now let's move on to the third classification. So first is on the basis of appearance. Second is on the basis of physical state. Third is on the basis of amount of solute. Third is on the basis of amount of solute. Okay. So let me take a beaker in which solvent and solute molecules are present. Now, sorry. This is the system where in which I have only the pure solvent. This blue color thing is a pure solvent, and these balls are actually the solute. These are actually the solvent molecules, and just give me a second. Yeah, sorry for the interruption, students. Yeah. Now, yeah, what I was saying, we have a solvent molecules inside the beaker, and now what I'm going to do, I am adding some particles inside this. Okay, all the blue color balls, everything blue color, so solvent, they are all pure solvent. Okay, blue color is a solvent molecule. And in the second beaker, all of you can able to see some purple color balls, right? So that denotes the solute molecules. Okay. So what do you observe here in this beaker? Solvent molecules are more in number compared to the solute molecule. So if this is the case, if the solvent molecules are more in number compared to the solute molecules, then that particular solution is called as dilute solution. It is called as a dilute solution. Okay. And in the second case, so here we have more number of solute particles compared to the first beaker. Okay, means this is called as a concentrated solution. Actually, in the second beaker, in this beaker, if you see, the solute particles and the solvent particles, they are almost equal in number. Okay, means it is a concentrated solution. If the solute particles are very less compared to the solvent molecule, it is a dilute solution. If the solute particles are almost equal with the solvent molecule, then it is called as a concentrated solution. Okay, clear? So in the first classification, we had homogeneous and heterogeneous. In the second classification, we had gaseous, liquid, and solid solution. And in the third classification, on the basis of amount of solute, we have dilute and concentrated solution. Okay, Rohit is asking on doubt. If solute and solvent molecules are same in number, then how can we classify? Mostly don't be the case. You cannot have the solvent and solute molecules equal in number. It will not form a solution. Okay, it cannot get dissolved with each other, right? So it will not form a solution in most of the cases. Got it? It is not called as a solution actually. Is that okay, Rohit? Yeah. Okay. There also we have some cases, but it is not given in your book. So I will discuss it later. Okay. I will discuss it later. Now, this concentration, which is also called as strength, Okay. So it is classified or it is taken into two. One is qualitative, and this qualitative is again classified into two. In the qualitative part only, we have dilute and concentrated term. Okay. And coming to the quantitative side, so quantitatively, we can measure the concentration of any solution. Okay. So quantitatively, we can measure the concentration of any solution using different terms. Okay. So the first term is called as mass percentage. Second term is called as volume percentage. Third is mass by volume percentage. Fourth is parts per million. Fifth is mole fraction. Sixth is molarity. And seventh is molality. Okay. So these are the 7 concentration terms in which we use to find out the concentration or strength of any solution. Got it? Is it clear for all of you? Are you all taking the notes? Are you all taking the notes? Yes. So have a notebook with you. Have a pen and pencil and everything with you. Try to take the notes. If you want me to stop anywhere or if I'm going very fast, if you want to note down anything and if you need some time to note down that, you can feel free to put that in the chat box. Okay, I will give some time so that you can take the screenshot or you can take down in your notebook, anything. Okay, so don't get scared or don't feel shy to stop me. Okay, fine. So these are the 7 concentration terms. And in the next slide or from the next slide onwards, I am going to discuss these 7 terms with you. Shall I start? Shall we go for the 7 concentration terms? One by one. Are you all ready? Okay. So 7 concentration terms are very, very important. Okay. So you will get more problems, more numericals, okay, and some theories also you will get from those 7 concentration terms. So the first concentration term is mass percentage. So for all the concentration term, I'm going to give you one formula, okay, and you are going to memorize that formula. So something we need to memorize, right? So here you are going to memorize all the formulas and we are going to apply those formulas into the problems and we are going to solve it. Got it? Now the formula to find out the mass percentage of any component is equal to mass of the component in the solution divided by total mass of the solution into 100. Okay. So in the solution, I may have different components, right? So if I want to find out the mass percentage of a particular component, then I have to specifically take the mass of that particular component for which I am going to find out the mass percentage. And then I have to take the total mass. In the solution, I may have different number of components. So I have to take the total mass of the solution and then I have to multiply it by the number 100. I'll give you one example so that you can understand better. Okay. So here I am taking 20% of sugar solution in water. So what is the meaning of 20% of sugar solution in water? It means 20 gram of the sugar is present in 100 gram of the solution. 20 gram of the sugar is present in 100 gram of the solution. So we have solution. Solution is equal to solute plus solvent. Solute plus solvent. So 100 gram is the mass of the solution. In that 20 gram is the mass of the solute and the remaining is the mass of the solvent. Is this clear for all of you? So this is the meaning of 20% concentrated sugar solution in water. All right. All right. Yes. Good. So what you need to do now? In some questions, they will give like this. If the mass percentage is 20% for sugar solution, find out the total mass of the solution or find out the mass percentage for the given system. So any type of question can be asked. You should understand the meaning for this. You should know what is meant by 20% first of all. Okay, W by W. So in mass percentage, everything is given with W by W. W means weight. Okay, so here we are taking the mass, right? Numerator also we are having the mass. So the unit is gram. And the denominator also we are having the total mass. Again, the unit is gram. So it is mass by mass, weight by weight. Okay. So 20% W by W means it is mass percentage. Clear? Yeah. Yeah, 20 is the answer. Good. Fine. So have you all taken down the formula and the example which I have given? Shall I go for the next concentration term?
Yes, ma'am.
Yes. Good. Thank you. Second is volume percentage. Volume percentage. So what is the volume of a component? So here it is denoted by B by B. Because in the numerator we are going to have the volume. The denominator also we are going to have the volume. So the formula is same as that of the previous case. Instead of mass, you have to put volume. Okay, volume of the component in milliliter divided by the total volume of the solution. Okay, it is also in milliliter into 100. So example, 20% volume by volume alcohol solution in water. What is the meaning of this statement? Can anyone tell me the meaning of this statement? What is the meaning of this? So we have a solution, okay, which is solute plus solvent. Solution will be, it is percentage, so it is 100 ml. And here, how much is the solute? What is the volume of solute here? Very good, very good. Yes. So 20 ml of alcohol, which is the solute here, it is dissolved in 80 ml of water. 80 ml of water. So 20 ml of alcohol. Alcohol is a liquid. Water is also a liquid. So it is a liquid in liquid solution. Okay. So 20 ml of alcohol is present in 100 ml of the solution. So 80 ml is the volume of. No, my dear, it is 80. Veena, it is 80 and 20, not 800 and 200. I think you have done by mistake. Okay. Good. Fine. So this is also clear, right? Volume percentage. Shall we go for the next? Shall I go for the next term? Yes or no?
Yes, ma'am.
Yes. Okay. So the next is mass by volume percentage. So what it is? So from the term itself, from the name, mass by volume itself, we can understand that it is W by B. Mass percentage by volume. W by B. So in the numerator, you will have the mass component, which is the mass of the solute, which we are going to take in terms of grams. And in the denominator, it is total volume of the solution. Solution's total volume. In the numerator, solute mass. Okay, into 100. Now I'll give you an example. 20% of W by B sugar solution in water. What is the meaning? What is the meaning? 20 gram of the sugar is present in 100 ml of the solution. Very good.
Solution.
20 gram of the sugar is present in 100 ml of the solution or sugar solution. Right? Yeah. The remaining 80 will be of water, and we can use density formula to convert the milliliter to gram. Okay, for water. So that way you can do. Yeah, very good, very good. So all of you are doing great, you know. Good students. So I think we can move on to the fourth term, fourth concentration term, which is parts per million. So we also have one formula to find out the parts per million. It is also represented as ppm. Okay, ppm. ppm is equal to number of parts of the component divided by total number of parts of all the components into 10 to the power 6 into 10 to the power 6. So here are some examples. Okay. So fluoride concentration in community drinking water. So here it is taken as an example for age 0 to 6 months. Okay. So it is less than 0.3 ppm. Okay. And if it is 0.3 to 0.6, again none. For greater than 0.6 also it is none. For 6 months to 3 years people, it is having 0.25 magnesium per day. And for the second case, it is none. So it is used to find out the concentration. ppm is the concentration term which is used to find out the concentration of some ions in the solution. Okay, some ions in the solution. We may have chloride ion, we may have fluoride ion, we may have magnesium ion, calcium ion in the water, right? So to find out the number of parts of that particular ion in the solution, this parts per million concentration term is used. Okay. Now coming to the next concentration term, the fifth one, which is mole fraction. It is denoted by the letter X. Okay, it is denoted by the letter X, or actually it is denoted by the letter like this. It is actually called as chi. Okay, it is called as chi, the Greek letter. We can call this X. Okay, instead of chi, you can call this as X. This is a mole fraction. And the formula to find out the mole fraction is number of moles of component divided by total number of moles of all the components. Okay, number of moles of that particular component divided by total number of moles of all the components. So what is the meaning? This formula is very, very important. Okay. Okay, Sneha is asking me to show the ppm slide. Okay, I will show you. Just take a screenshot or note it down quickly. Let me know once you're done with it. Let me know once you're done with it. Neha, finished? Yes. Fine. Yeah, now coming to the mole fraction. What is the meaning? What is the meaning? This is an important formula which we will be using in many concepts. Okay, in many concepts. So let me take a picture. Let me take a beaker. I have A component and also I have B. Okay. So for the component A, I can find out the number of moles of A present inside the solution. So where Na is called as the number of moles of A. Okay. And for the component B, so here I may have some B component also. Okay. And the number of moles of B can also be calculated and it is denoted as NB is called as number of moles of B. Now, what I want to do, now I want to find out the mole fraction of A alone. Okay. If I want to find out the mole fraction of A alone, then I should write it as XA. So, XA will be equal to number of moles of that A divided by total number of moles. Totally, I have only two components. One is A and the other one is B. Okay. So now I'm going to find out the mole fraction of A. So XA is equal to number of moles of A divided by total number of moles, which is Na plus Nb. Got it? So in the same way, if I have to find out the mole fraction of B, what I have to do? What I have to do? Xb is equal to Nb divided by Na plus Nb. Right? Yes or no? Is it clear for all of you? I am finding out the mole fraction of
Yes, ma'am.
B alone inside this container. To find out that, take the number of moles of that component divided by total number of. I may have 3 components also. If I am having 3 components, then what do I need to do to find out the mole fraction of A? XA is equal to NA divided by NA plus NB plus NC. Are you getting my point? So to find out the mole fraction of any component, take that component divided by total component. That's all. Very easy. And one more important point is the sum of the mole fractions. So here we have only 2 components. The sum means XA plus XB. So that will be equal to 1. XA plus XB will be equal to 1. So this, why I'm saying this formula is very important means, so in some questions, we may require to find out the mole fraction of both the components. So in that case, you don't have to apply these 2 formulas and do all the calculation, multiplication, division for both. Just find out the mole fraction of one component. So for example, I'll take, let me say I'm finding out the mole fraction of A. So using this XA formula, I'm getting one value here and I can just substitute here in this formula, right? To find out the value of XB. XB is nothing but 1 minus XA. So here I have got one answer, right? Just substitute that here and subtract it from 1. You will get the value of XB. You don't have to do the calculation again using this formula to find out XB. Got it? Is it clear for all? Understood?
Yes.
Yes. Now let's do one question based on this mole fraction. Okay, let's try to apply what we have studied. So the question is, if 4 moles of alcohol and 6 moles of water are mixed, then calculate the mole fraction of each component. So what are the 2 components? Alcohol is A and the water is B. Water is B. Okay, Sneha is giving me the answer. Okay, let me check. Okay, so the number of moles of A and B is given. So 4 is nothing but number of moles of A, 4 moles of A, okay, and 6 moles of B. So NB is equal to 6. And calculate the mole fraction of each component. So what we are asked to find out? XA, mole fraction of A we have to find out and mole fraction of B we have to find out. Has anyone got the mole fraction of A?
Yes, ma'am.
Yes, many of you have got the answer. Very good, very good. So the solution goes like this. XA is equal to 4 by 4 plus 6, which is 4 by 10 actually, 0.4, and for mole fraction of water, it is 6 by 10, 0.6. Okay, and the sum of the mole fraction will be equal to 1. So 0.4 and 0.6, if you add together, it will be 1. Okay, if you're not getting 1, then you must know, you should know that you're doing some mistake. Okay, if you're not getting 1 by adding the 2 components, then you should be knowing that you are doing some mistake and you have to cross check your answer. Okay. Good. Great. 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 Very good, students. Very good. All of you are so enthusiastic and so energetic, you know. I want you all to keep this spirit till the end. Okay, till the end, you all should be maintaining the spirit, and I hope you all will do that. And I hope you all will do that. This is a physical chemistry lesson. Solution is a physical chemistry lesson. And you guys are so energetic in this, you know. Yeah. Yes, Kalaburgi students, it is correct. It is correct. 0.4 and 0.6 is correct. So I have given the answer on the slide, no? It is correct. Shall I go for the next term? Shall I go for the next concentration term? So how many terms we have completed? We have completed 5, right? Yeah. Yeah, the 6th term is molarity. The 6th term is molarity. No issues. You are welcome, Kalaburgi. Fine. The molarity. So what is molarity? So the sixth term and the seventh term which I am going to discuss are very, very important. Molarity and molality, they are very, very important. So what it is? It is the number of moles of solute present in 1 liter of the solution. It is the number of moles of solute present in 1 liter of the solution. So mathematically, how can I write this one? Molarity is denoted by the letter capital M. Okay, it is denoted by the letter capital M. So molarity is equal to number of moles of solute divided by volume of solution in liter. Okay, volume of solution in liter. Suppose if number of moles is not given to us in the question, instead of number of moles, we are provided with only the mass value in the question. Okay, we have the mass in the question, but we don't have the number of moles in the question. So in that case, what you will do? How will you find out the number of moles? Any idea? Yeah, very good. It is given mass divided by molar mass. It is given mass divided by molar mass. Very good, students. So the number of moles is equal to the given mass divided by molar mass. Yes. Really great. Great, great, great. So this is how we are going to. So if you have to check with the volume also. If the volume value is not given in the liter unit, you have to convert it into liter. In many questions, you may have the volume in terms of milliliter. So in that case, you have to convert that into liter. Then you have to substitute here in this formula and get the answer. Okay. So please memorize this formula. Memorize all the formulas thoroughly. And this formula especially, you should not make any mistake. Okay. Even if I ask you when you're sleeping, you should be able to answer it correctly. Got it? So don't make any mistake here. This is the only simple formula which you can memorize so easily. Now, let's do one question based on this molarity concept. Okay. Yeah. They calculate the molarity of a solution containing 5 gram sodium hydroxide in 450 ml solution. What we need to do? How to calculate the molarity of a solution containing 5 gram sodium hydroxide in 450 ml solution? Whenever you are provided with physical chemistry questions like this, first thing you need to do is write down all the given information in the question. So what is given in the question? We have 5 gram of sodium hydroxide. 5 gram means what is the term? What is given for sodium hydroxide? Mass is given. Okay, so 5 gram is the mass of sodium hydroxide. And 450 ml is the volume of the solution. Okay, 450 ml solution, right? So it is the volume of the solution. Clear? Now, we are provided with only mass. We don't have moles. What we have to do? Use the number of moles formula which we have discussed, which is given mass by molar mass. So are you getting 0.27? Let me check, my dear. Let me check. Okay, many of you are getting around 0.28. Oh, molarity. Great. So given mass is 5 gram. And molar mass of sodium hydroxide is how much? Has anyone got the answer for the molar mass of sodium hydroxide? How to calculate the molar mass? Many of you know how to calculate it. Yeah, it is 40. Very good. So some of you might not be knowing how to calculate. Okay. So for those students, I'm going to explain quickly like how to find out it. So we have one sodium, one oxygen, and one hydrogen in the compound. So the atomic mass of one sodium is 23, and the atomic mass of oxygen is 60, and for hydrogen it is 1. So if I add everything, I will get 40. and this is the molar mass of sodium hydroxide. Okay. So what I have done, sum of the atomic masses will give me the molar mass. So ma'am, how do I know that this is the atomic mass of this element? So that you need to memorize. Okay, all these you might have studied in your class 11. Yeah, class 11. So for some elements which are very common, for those elements you have to memorize. Like for oxygen it is 16, for hydrogen it is 1, and if I take carbon it will be 12, and if I take nitrogen it is 14, and if I take copper it is 63.5. Okay, and if I take chlorine it will be 35.5. And what else is common? So these are the very common elements. So for these elements, you need to know the atomic mass values, and by substituting and adding everything together, we will get the molar mass. So it is 5 by 40, and which will give me 0.125 mole as the number of moles of solute. Okay. So here I am giving you the answer directly, or you might be having this question in your book also. Okay. So getting the answer by seeing the screen is not important. After this class, you have to sit and solve whether you are getting 0.125 as the value for 5 by 40 or not. You have to do the division. Okay, only by doing the division and multiplication many times, you will get used to it, and it will be very easy for you in your exam. It will not take much of your time. Okay, so I have the number of moles. Now what is the next thing? I need to have the volume. Volume in terms of liter. So how to convert milliliter to liter? Do I need to divide it by 1000 or multiply it by 1000 to convert milliliter?
Divided by 1000.
Sorry?
Divided by 1000.
Very good. So I have to divide. To convert milliliter to liter, you need to divide the term by 1000 or 10 to the power 3. 10 to the power 3 is 1000. Okay. So if I divide it, I will get the answer. I will get the answer, and you can keep this as such also. For the simplification purpose, you can keep this as such also, 450 by 1000. Now substitute these two number of moles and volume values in the molarity formula. So in place of number of moles, 0.125, and in place of volume, so in the denominator I have the volume, right? So it will be 450 by 1000. So that 1000 which is there in the denominator of the denominator will go to the numerator. So that's what I have done here. 1000 is there in the numerator. Now after solving, cancelling out this and solving, I will get 0.278 molar as the final value for this question. So this is a known question for you guys. All of you might have been solved in your class, right? Yeah, 0.278, or you can also approximate it into 2 decimal. So you may also have 0.28 molar. That is also correct only. Okay, since it is greater than 8, you can have it as 0.28 also. It is also correct. Okay, clear?
Yes, ma'am.
Shall I go for the last term, molality? Molality is number of moles of solute present in 1 kilogram of solvent. Yeah, 1 kilogram of solvent. So, for molarity and molality, numerator remains same. In the numerator, you will have number of moles of solute. That remains same. Only the denominator changes. In the denominator, we have mass of solvent in kilogram here, and in the previous case, molarity, we had volume of solution in liter. Okay, and there we used to represent it as in capital M, and here you have to use small m for molality. Okay, so only the denominator changes, remaining things are same. Unit you have to be very careful. You have to represent the solvent mass in terms of kilogram unit. Okay, if it is given in gram, convert it into kilogram and then do the question. We'll do one problem and then we'll wrap it up the today's session. Okay, so here is the question. Calculate the molality of 2.5 gram of ethanoic acid in 50 gram of benzene. Molar mass of ethanoic acid is 60 gram per mole. So everything is given, right? Molar mass is also given, and 2.5 gram of ethanoic acid. So ethanoic acid is one component and benzene is another component. So benzene is a liquid. It is a solvent. Benzene is a solvent. So what is this 50 gram? This is the mass of solvent. So like water, benzene is a solvent. And ethanoic acid is a solute here. Okay. So molar mass of solute is given to us. Mass of the solute is also given to us. Then according to molality formula, we need to find out the number of moles, right? Using given mass by molar mass, which is 2.5 divided by 60, which is 0.04. And the mass of benzene is given here in terms of gram. Convert it into kilogram. To convert gram to kilogram, you have to again divide it by 1000. So it will be 50 divided by 1000, which is 0.05 kilogram. Now substitute in the main formula. So substitute both the values and get the answer as 0.834 molal. Okay. Is it clear? Is it clear for all of you? Yeah, 0.834 molar. Mostly, if you're solving the questions from concentration terms, especially molality and molarity, go for the 3 digits after decimal. Okay. You can also stop up to 2 or 1. So it is according to the question. Okay. And the options which is given to you in your NEET and JEE examination. Okay. So mostly go for 3. And then it is up to you. It is the most common and the most widely used term to measure the concentration of any system, because it involves the solute moles and the solvent mass and the solution volume, right? In most of the industries, if you see, they'll represent it in terms of molarity and molality only. Got it? So that's why we go for this for many things. Clear? To measure the strength of any solution, we go like this. In pharmacy, in many syrup bottles, if you see, you will have the concentration term, that mass by volume. The W by V we had to, that we have, and volume by volume percentage will be used there in pharmacy related issues. Okay. In that case, we'll have that. In some case, we'll have molarity. Okay. Okay, students, thank you so much. So here I am closing the today's session. So today we have studied the introduction and the introduction to solution and the concentration of concentration terms, 7 terms, which is being used in the solution. And we have discussed some problems also, some very basic problems I have took for you, which is there on your book. And in the next session, in the next class, I will discuss some more problems on this molarity and the concentration terms, and then I will move forward to the next topic. Is that okay? So do any of you have any doubt? ppm. So parts per million. So you just need to take the number of parts of that component divided by the total parts of all the components in the solution into 10 to the power 6. It's just a formula, no? So we are finding out the number of parts of a particular ion in the total solution by having 10 to the power 6. Yeah. Okay, students, I hope everything is clear so far. So go and study. If you are getting any doubt, bring those in the next class. Okay. Thank you. Thank you so much. See you all in the next session. Bye-bye.
Thank you, ma'am.
Thank you.